So, we are recording. Kind of going back up, we just said we're looking for the greatest common factor. We use the greatest common factor when we're simplifying, and our factors will always start with the number 1. Okay? So, if we're looking at just the first way we can find the greatest common factor is by listing the factors. What are my factors of 14? Wait, what do we always start with? 1. Then 2, 7, 14. Okay? What are my factors of 20? 1. Hey guys, let me back up and say this. Your first factor will always be 1. Okay? 2, what else? 4, 5, 10, 20. Alright, when you list factors, it should make this nice little rainbow. 1 times 20, 2 times 10, 4 times 5. There are your factor pairs. Okay, let me remind you, I'm recording this. Okay, thank you. Alright, looking at these two numbers, what is the largest number they both share? 2. Guys, it's not always going to be a huge number. The greatest common factor between 14 and 20 is 2. And that's all we're looking for. We're not trying to simplify. We're just looking for the greatest common factor. Yes?
When you're doing like the number 2 or 42, you can do 3. So it doesn't have to go, it can't go over 12. It can go over times 12 or do that without a 12.
For which one?
Like for 42, like you go.
Okay, we're not there yet. Hold tight. We'll get to that one. Hang on. Alright, so now let's look at our factors of 16 and 42. What is my first factor of 16?
1,
2, 4, 8,
16.
16. Okay? What about 42? 1.
6.
Hang on. 2.
6.
Let's pause. 3. Very good. How'd you know 3?
Because if 6 can go into it, then you can make it smaller and that becomes a 3.
Bingo. Remember we talked about our 3 rule? If I can add these two together, 4 and 2, that's 6. 6 is divisible by 3. So 42 is divisible by 3. Alright?
I can try 3.
Okay. 6, 7.
42.
Hang on. Alright, if I'm looking at this, 6 times 7, 3 times what?
21.
Not quite.
14.
14. Very good. Then 21, and then 42. Okay? Again, what is my greatest common factor?
2.
2 is it. The largest number they both share happens to be 2. Okay, so this method you've seen before, right? Listing your factors, finding the largest one they share. Okay, so let's try a couple more. 45, what's my first one?
1.
1.
Not 5.
What about before 5?
4. 3.
3.
Yeah.
5.
How many times can 42 add 3, 4, 5?
Alright, 5 times what? 9. Very good. Then 3 times.
12. 13.
Say it again. 15. Very good. And then the last one, 45. Okay? Looking at 30. 1, 2, 3.
4.
What about 5, 6.
And 8.
3 times what? 10. And 2 times 15. And lastly 30. So what is my greatest common factor?
15.
Very good. So again, you're just listing all of your factors and then finding the largest one that they share. Okay, let's do one more this way, then I'm going to show you another way. So we've got 36 and 54. Again, first factor is 1. Then what? 2.
6. 3.
Hang on, back it up. 3.
4.
4. Very good.
6.
Okay. So at this point, yeah, we have 6 times 6, so then 4 times 9. 3 times
12.
2 times
27. 17.
close.
18.
18. Very good. And then the last one is 36. All right. 54. 1, 2, 3. Very good. 4 will not.
5.
Guys.
6.
6 times, what'd you say, 9? Okay, so let's now look at 3 times what?
3 times 18.
Very good. 2 times
2 times
20,
22.
27. And then the last one's 54. Okay, what is your greatest common factor? 18. Alright, be careful, because this one had several common factors. 1, 2, 3, 6, 9, but 18 is the greatest common factor.
When we do it, do you want us to write GCF?
Yes. Yes.
See, I keep writing 2. This is these. Oh, wait, hold on. Thinking that.
You're looking at the vocab.
Yeah, I was saying this says least common factor.
Multiple.
Okay. Shh. Let me remind you once again, guys, we are recording. And the more you talk, the less time you have to start homework. All right. There is one other way I want to show you how to do this, okay? So we're good. We've seen this before, listing just the factors and finding the greatest common factor. Now we want to use prime factorization. What is a prime number? Okay.
A number that can only be multiplied by itself and 1.
Absolutely. So its only factors are 1 in itself. So your prime numbers would be numbers like 2, 3, 5, 7, 13, 6 is not a prime number. 9 is not a prime number.
17.
Very good. So be careful. 1 is not prime. It has to be greater than 1.
23.
So listen carefully. A lot of people want to get in the habit saying odd numbers are prime. That is not true, because 9 is an odd number. 9 is not prime.
21 is odd.
21 is odd. It is not prime. So we are looking for just prime numbers. So if we're looking at 18 and 30, hey, hold on just a second. I'm going to wait till everybody's ready. Okay, so I have 18 and 30. I'm going to start with the number 18. What are 2 numbers I can multiply by each other to get 18? Allie Grace. 9 and 2. Okay, are either of these prime numbers?
Yes. No. Yes.
2. I'm going to circle it.
2 is prime. No, yes.
Okay?
9 can be multiplied by 3.
9 can be split up 3 times 3. Are those prime?
Yes.
So I'm going to circle those. Your goal is to get to where all you have are prime factors. That's why it's called prime factorization. So if I write this out, this would be 3 times 3 times 2.
18.
So if I look at this, 3 times 3 is 9. 9 times 2 is?
18.
Okay. These are the prime factors of 18. Okay? So now we're going to do the same thing with 30. What are 2 numbers I can multiply to get 30?
15 and 2.
Okay, 15 and 2. Is 2 prime?
Yeah.
I'm going to circle it. 15 can be broken apart into
3 and 5.
3 and 5. Are they prime?
Yes.
So now I have all my prime factors. So this will be 3 times 5 times 2.
That's a lot easier.
At Alright, at this point, I want to look for all the numbers they share. Okay? 3 and 3, 2 and 2. So if I look at this, what is 3 times 2?
6.
Again, down here, 3 times 2. So my greatest common factor is 6. Now the great thing about using this is that if you are wanting to simplify, like if you're finding the greatest common factor for the purpose of simplifying, whatever is left over is your simplified fraction.
6 could go into rows 18 and 30, but it would be different if you used them.
So I'm saying follow along.
Okay.
Watch what I'm doing. Yeah. Okay? Yes?
All odd numbers have a 3 when you spread.
All right, so let's look at this. Everybody see how I ended up getting 3/5?
Yeah.
Okay. What's left over after you take out your greatest common factor is your simplified fraction. So if I have 3 and 2, I take those two factors out. 3 times 2 is 6. That's my greatest common factor. The only thing left is going to be what my fraction would be if it were simplified. 3/5. Okay? All right, let's try another. The next one we have 60 and 45. Okay? 60 and 45. So how am I going to multiply to get 60? Cole.
You can do 2 and
30. Okay? So which one is prime? 2. Okay, so now I got to split apart 30 and I get 3 times 10. 3 is prime. How am I going to split apart 10? 5 and 2. And those are both prime. So at this point, my prime factorization of 60 is going to look like 2 times 3 times 5 times 2. Okay? Let's look at 45. How do I get 45?
5 and 9.
5 and 9. Okay? 5 is prime. How do I split apart 9? 3 and 3. And those are both prime. So now I have 5 times 3 times 3. All right. Now I'm looking for what matches. I have a 5 here and a 5 here. I have a 3 here and a 3 here. Does anything else match?
No.
No. So what is my greatest common factor?
5 and 3. Or, 15.
15. Okay? Now, if we were trying to simplify 60 over 45, I have 2 times 2 left, which is 4. And I have 3. So 4/3 would be 60 over 45.
Which is 1 and
That's kind of another third, but
It absolutely is. To me,
it's not easier.
And that's fine. If it's not easier for you, then you don't have to do it this way. For some people, this makes more sense because it breaks the numbers down, especially larger numbers. It breaks it down into much easier numbers to deal with. All right, let's do one more, okay? So 24 and 36. Here we go. 24 and 36. So how am I going to multiply to get 24?
2 times 12.
2 times 12. Huh? You can do, okay, all right, that's a great question. All right, let's do this one and then I'm going to show you something. All right, so 2 and 12, which one's prime?
2.
How do I split apart 12?
4.
Which one's prime?
3.
How do I split apart 4?
2 and 2.
And they are both prime. So my prime factorization is 2 times 3 times 2 times 2. Now, great question just a second ago, and I think a couple of people are thinking this. So let's look at this. If I still have 24, we've done 2 and 12. Let's do 6 and 4?
Yes.
Okay, neither are prime. So that becomes 3 and 2, right? And those are both prime. 4 becomes 2 and 2. Look what happens.
Same thing.
3 times 2 times 2 times 2. I got 3 2s, 1 3. Same thing. Every single number has its own unique prime factorization. So no matter how you start multiplying, you're always going to end up back at the same prime numbers.
So it's what so the 6 and 4 you multiply together to get 24.
Yes. And this is how do I get 6, and this is how do I get 4.
So it could be any way that you get 24.
If I could do, let's do 24. We could do 8 and 3.
Yes.
So that's prime. That's 4 and 2. And that's 2 and 2. So we still have 1, 2, 3 2s and a 3. No matter which way you start multiplying, you're still breaking the number down until you get to the same prime numbers.
So it doesn't matter what numbers you start
No.
with as long as they equal the number at top.
Bingo.
Okay, now that makes sense.
Yes. Uh-huh.
So is the prime number the smaller number?
The prime number is the number that when you get to that part, there's no other way that you can multiply to get it. The only rule is don't use the number 1.
Oh,
Okay? Now, let's say, for example, I'm trying to think of one. Let's say we're doing a prime factorization and we're matching our numbers and there are no numbers left on the top. What would you use? What's the first factor of every number? 1. So if you've matched your numbers and there are no numbers left on the top, your numerator is going to be 1. Let me show you. All right, let's try this one, okay? And this is not on your paper. This is just for example. I'm trying to think of one. Let's do 14 and 52, okay? So let's break apart 14. What do we? 2 and 7. Okay. They're both prime. So 7 times 2. That's it. All right, what about 52? 2 times... I'll go 2 times 26. Okay, so 2 is prime. How do I get 26?
13.
2. 13. Okay, prime. So if I look at this, I've got 2 times 13. Okay? Well, that didn't work out the way I wanted it to.
What do you add another 2? 2 times 13. What were you trying to do?
Oh, I used the wrong number. All right, stick with me for just a second. Let's do this again. 14 and 42. Sorry. So 14, we figured out that's 7 and 2, right? So that's 7 times 2. Sorry, I used the wrong number. So 42. Now we can say 2. 21. So that's prime. And then how do we get 21? 7 and 3. Those are both prime. So now we have 2 times 7 times 3. Yes, this is going to work. Sorry, I used the wrong number. All right, finding ones that match. 7, 7, 2, 2. So this is where I was saying, if nothing is left up top, there's nothing left up here. And if I was simplifying this, can't we always say times 1?
Yes.
Absolutely. So your leftover fraction would be 1/3. And what would be your greatest common factor?
14.
Yeah. So if there's, what I was trying to show you is if there's nothing left over, you can always multiply by 1. Now, when we're doing prime factorization, you don't want to use 1 because we would go on forever. I mean, we could say times 1 a million times and we're going to get the same value. So just don't use the number 1. But when you're factoring a number, and they're called factor trees because they end up looking like trees. Let's do a large number just so I can show you how it breaks it down.
220.
220, let's do it. So 220. Okay, so what are 2 numbers we can multiply?
2 and
110. Okay, this is prime. How do we get 110?
2 and 55.
55 times 2. Okay.
5 and 11.
That really didn't go bigger than I thought, but okay. So at that point, all of these numbers I can't split up anymore. I don't have 2 numbers I can multiply to get 5 other than 1 and 5, and I don't have 2 numbers I can multiply to get 11 other than 1 and 11. So that's how you know you've gotten down to your prime numbers is when that's it. Does that make sense a little bit? Okay. Yes. How did I get 15? Number 6. Let's look at this right here. Because when we look at our greatest common factor, when we look at our factors, 3 and 5 are the ones that match for both. So I'm going to multiply 3 times 5. So that would give you 15. Yeah. All right. So I am going to let you guys actually turn to the back of your paper real quick, and let's do
33.
Let's do the hardest one together.
I'm trying to find one. Let's do together.
120, 112, and 88.
Okay. Shh. Look at number 6. 78 and 48. Okay. I think you guys are probably more confident with listing your factors, so let's try this one using the prime factor trees. So we've got 78 and we've got 48. Okay? So what can I multiply to get 78?
2 and
It's even, so we always know we can start with 2.
Oh wait, hold on. 26. Or
No.
not 26. 20. Hold on. 26. Yeah. 36.
39.
39.
Very good. 39. Okay, so 2 is prime. 39 is not, is it?
No.
Okay, so what would we multiply to get 39?
3 and 13.
13. And those are both prime. Okay, so our prime factorization of 78 is 2 times 3 times 13. I prefer these numbers and dealing with them over 78. So I think that's, to me, why this one might be a little more helpful. All right, let's try 48. How can we multiply to get 48?
2 times 29.
2 times 20.
24.
Okay, so prime. What about 24?
2 times 1, 2.
Okay. And what about 12?
2 and 6.
2 and 6. What about 6?
2 and 3.
Woo, this one's making a long one. Okay, so now we have 2 times 2 times 2 times 2. There's 1, 2, 3, 4, and a 3. 1, 2, 3, 4 times 3. Okay, at this point, again, looking for what's matching. 2, 2, 3, 3. That's it. So, 6 is your greatest common factor. I think, to me, this way is so much easier than sitting here going, okay, 1 times 78, 2 times... Because as you're going, your numbers are getting smaller and smaller. Does that make sense? All right. Listen very carefully because I'm about to give you guys instructions that I will send out on Remind later. This was number 6, right? Only do the even numbers. Okay? Only do the even numbers. Not yet. I'll send it out on Remind.
Morgan, she's done like half the page.
Okay.
No.